The drone drives until a hill is detected. When a hill is detected, it rotates by a random angle accordingly. This randomness aspect is once again required to ensure that the entire terrain is covered.
We're going on an adventure!
The robot drives until a cliff or boundary is detected. When the obstacle is detected, it rotates by a random angle accordingly. This randomness aspect is required to ensure that the entire terrain is covered. The robot will check if a rock sample is detected, align itself accordingly, and open the clamp. It will then drive in a straight line towards the sample. If the clamp sensor detects that a sample is inside, then the robot will stop, close the clamp, and take the sample back to the lab. Once a rock sample is in the clamp, the robot will stop and spin upon its axis. It will drive towards the highest IR intensity detected. If no obstacles are detected within 5 seconds of driving, it will repeat this loop. Otherwise, the robot will turn and drive around the obstacle at a right angle. The motivation for this is to efficiently traverse towards the beacon. If there is a rock sample in the clamp of the robot, it then checks if the base is occupied by the other drone. If it is free, then it starts searching for the beacon and hence the lab. Once it leaves the base, it communicates with the other robot that the lab is now free. The reason for this is to prevent collisions in the base. Once the robot reaches the beacon, it checks for the black entrance line on the ground. It enters the base and drives forward towards the drop-off location at the lab. It drops the sample and drives in reverse to exit. It then positions itself so that it can continue exploring.